This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Hi there, welcome to another episode of Design Safe Radio. I'm your host, Dan Zahner, and on this special episode, we talk about the NHERI Science Plan with Ian Robertson.
What are some of the things that you've seen over the years of developing the first through the third edition of the Science Plan that have guided research and we've seen some outcomes? Now we've been at this for a few years and are starting to see some of the outcomes. What are some of those that you've seen?
Yeah, so we've had a number of excellent feedback on the first and second editions of the Science Plan. And in fact, we're now incorporating in this third edition some examples of how research projects that were initiated by earlier science plans have been taken through to implementation. So from inception to implementation, and through the research, publication, promotion at standards and building code committees, and eventually being incorporated into design standards that are adopted around the country. And so we have that sequence of events for a number of different research projects undertaken by NHERI. And we highlight those in this science plan as examples of what you can achieve if you take a very simple concept and work it through the NHERI process to come out successfully and get it into practice. We also focus on a new committee that was initiated by the NCO, the Network Coordinating Office, called the TTC, the Technology Transfer Committee, which looks to helping researchers move that final step from the end of their research. They've discovered their findings. They know what we need to do to improve the performance of buildings under these natural hazards or other structures. But the last step to take it into implementation, into code committees, and getting it into a standard or a code is a difficult one. And so the TTC helps with that final step, puts them in touch with the right people in committees. And in fact, the TTC is now trying to get involved with researchers at the beginning of their projects to make sure that the work they do in all of this research is something that can be applied in the end of the day. And so we feature the TTC in the third edition of the Science Plan, and we show how they can help, particularly junior faculty who are less familiar with the practical side or the practicing engineering community, help them guide their research and get it implemented.
Yeah, that is a big advantage to our way of doing things, because we're focused on the engineering side of these hazards, and we've got plenty of smart folks out there who are studying the geotechnical fundamental science and the meteorology fundamental science and the ocean fundamental science, but we're focused on engineering, which at its heart is about practical applications of all this.
Right. But a lot of the research that comes out of this type of network doesn't always get into practice, or it takes a long time before somebody will pick it up and move it into practice. We'd like to accelerate that process. We also, in this new third edition, we provide a roadmap for researchers to develop a team of the appropriate people for their research project, which in many cases will include a social scientist or a practicing engineer familiar with the field that they're working on, who can then help them move it into practice. But having a social scientist involved, at least one, maybe more, with different interests in the social science area, can help make sure that the research is appropriate, that we're not developing a widget that nobody's ever going to use because it doesn't make either economic sense or it's never going to be accepted by society. And I think of examples like putting up massive seawalls to prevent storm surge and tsunami. It's something that other countries, particularly Japan, have done frequently. I don't see that happening in the US. A, the expense, and B, the social implications and the aesthetics. It's not going to gain acceptance. So maybe we don't spend a lot of time researching that. Maybe we look at other ways that would be socially acceptable. And so, yeah, there are a lot of advantages to including a multidisciplinary team rather than just focusing on, okay, we engineers are going to solve this problem. Because, yeah, you'll solve the problem, but nobody's going to use it because it's not appropriate for society. So, yeah,
Right.
I think we do a good job of encouraging that in our roadmap to success.
It sounds almost similar to some universities, my home institution, Purdue University being one of them, having a startup incubator coming out of their technology. Hey, let's help you get this to practice, to build the business plan, to build your team, to do all those things you were talking about that an engineer or scientist doesn't typically think about, and maybe doesn't need to, as long as they're able to bring that team together and say, I'm not an expert in marketing, but this person is.
Yes. Yep. Yeah, a lot of those innovation centers at universities, and obviously we have one as well, they're actually more interested in things that can be patented and will generate income, both for the inventor and for the institution. Civil engineers, in many aspects, are a little different. Most of the innovation in civil engineering becomes public knowledge. Yes, there are some widgets that are licensed or patented, but that's the exception. Most of what NHERI produces, and NHERI particularly because it's funded by NSF, the results are freely available to anybody. And so, yeah, much more difficult to patent a concept, which we don't really encourage. We encourage broad use. We don't want people to have to pay a license fee to be able to make their building resilient to hazards. We want them just to have it free. So that is a sort of difference between civil engineering and mechanical electrical, for example.
Yeah, and that's what what we constantly highlight the importance of that investment in NHERI. And you look at actually some states right behind me from a couple of years ago when a hurricane was hitting. These states that some of them don't actually have a lot of the dollars from the NSF coming to their state institutions or organizations directly, but they receive a lot of benefit from that because of this public knowledge that would generate.
Exactly. And I'm sure that's a lot of what's behind the fact that NSF requires that within a certain amount of time, all of this knowledge is posted on DesignSafe and made available publicly. Anybody can access it. And there's an enormous wealth of information available there now that people can use.
Yeah, to that point, sometimes the enormous wealth of information can be a bit overwhelming. So if I was a new researcher who's just going to NHERI to start a proposal to the NSF, it's my first research project, where would you start?
Good point. Yeah, so good question. Well, I'd start by looking up the science plan. It will be published. We're hoping end of October, early November, it'll be available online. I would start by working through that, looking at ideas. We do include one appendix with 7 what we call research campaigns. They're relatively large scope potential campaigns that a group of people or a number of different organizations, agencies could get together and develop a collaborative research program to try to tackle those research campaigns. But there are a lot of good ideas in there of what needs to be done. And even an individual researcher could pick a single item out of one of the research campaigns to say, that's my specialty, I'm going to focus on that. Though even so, we encourage adding team members who can broaden your thinking, because we often get trapped in our own little mindset as we tackle an individual problem. But yeah, so I would work there first. Now, the second edition of the science plan also has another 5 of those research campaigns, and they're not the same. We intentionally didn't just upgrade the old ones. They're perfectly good on their own. We've added essentially another 7 research campaigns. So those may give a new researcher some suggestions. The DesignSafe database is still a little difficult to search. But the TTC I mentioned earlier, the Technology Transfer Committee, is working with DesignSafe to develop a search engine that will bring up research on particular items. So based on search words, you could bring up all of the research in a certain area. It may still be difficult to get to the actual data behind those, but at least you'll find the projects and the associated PIs, principal investigators, who worked on that project. And you would then contact them and find out from them where you can find, in DesignSafe, where you can find the data that they generated. And it is enormous. I'm a co-director of STEER, the Structural Extreme Event Reconnaissance Network, and we already have easily over 40, 50 projects in DesignSafe with innumerable images and aerial scans and LiDAR and street view imagery for 40 plus hazard events that have happened around the world over the last 5 years. All of that data is freely available. And so if you're researching the performance of roofs during hurricanes or the performance of different framing elements during earthquakes, it's there. There's a lot of information available. Finding it is the tricky part.